Thank you. Thank you, Julian. Thank you for the introduction. Again, my name is Luisa Moreno. I am the president of Defense Metals. I will be introducing you a very exciting opportunity in defense in the rare earth space. So key accomplishments of the companies. We acquired this year 100% of the WICHEEDA rare earth project. And it has a tremendous potential to reach production, and I will explain to you why. We also completed, in January, we actually filed our preliminary economic assessment, which shows significant increase in resources relative to the first resource report that we presented. We also improve our recoveries and metallurgy significantly. The project is quite robust, and I will explain to you why we believe that. We have also been building the technical team, and now we are in a position to bring significant value to our shareholders. The company currently has 40 million market cap, approximately. We have 160 million shares outstanding, and in a fully diluted basis, we have about 200 million shares. As many of you know, rare earths are critical for many industrial applications. The most known industrial applications that many of you might have heard is in electric vehicles. Neodymium and praseodymium specifically are used in permanent magnet motors that go in electric vehicles. But they also use in wind turbines for efficient lighting and other green applications. But it does not stop there. Rare earths are used in cancer treatments, are also used in MRI machines for 3D imaging, in chemicals and catalysts, for instance, for emissions control, and for oil refinery. In agriculture, is used, for instance, as a fertilizer. In computing, one known application is hard drives. In environmental, is used for water cleaning, for instance. And aerospace, one critical application is, for instance, in light alloys. And in defense metal, like, for instance, in missiles and other high-tech applications. Currently, China still controls the supply chain of rare earths. 10 years ago, in say 2012, China used to produce about 95,000 tons of rare earths, accounting for about 90% or more. The total production in 2012 was about 110,000 tons. And today is 240,000 tons. China produces today about 140,000, but only controls about 60% of the mine production. However, China still accounts for more than 85% of the processing. For instance, the second largest producer, as some of you may know, is a company called MP Materials that produces a mineral concentrate and exports that mineral concentrate to China. They account for about 15% of the world production, with 38,000 tons. What we want to do with WICHEEDA is to introduce an additional 25,000 tons and potentially position ourselves as the fourth largest producer. With that, we will account for just over 10% of the global production. So this slide shows a little bit more information about the electric vehicle as a driver for rare earth demand. Some estimates, like the one shown in this graph, suggest that by 2035, of the total passenger vehicles that will be sold, roughly about 40% will be electric vehicles. And when that happens, the demand for neodymium and praseodymium will double compared to today. which means we will have to double the production of rare earths as well, because they all occur together. And as some of you may know, the permanent magnet motors with the rare earths are the most efficient, build the most efficient motors, and many of the companies have adopted them, including Tesla, General Motors, Ford, Toyota, and so forth. At WICHEEDA, we have predominantly light rare earths, and this is important and is good because it allows us to have a high percentage of neodymium and praseodymium, which account for more than 90% of the economic value of our deposit. But we also have cerium and lanthanum, which accounts in terms of volume for the largest volume, but not the largest or the highest economic value. Cerium and lanthanum are also important. Cerium is also used to make magnets, but not as strong ones as neodymium and praseodymium. And lanthanum is used, for instance, in oil refinery. But rare earths are used in many other parts of the car, and this is what we want to bring to your attention with this slide. So where are the rare earth prices today? They are going up again. So some of you that have been following the rare earths know that back in 2010, 2011, all the rare earth prices went up quite significantly. This is not what is happening today. Prices of lanthanum and cerium have stayed quite stable, while the prices of many of these magnet elements have increased significantly. So this graph shows the price increases of neodymium last year, and today neodymium and praseodymium have prices close to $200 per kilo. So much higher than what I'm showing you in this graph. But the point that we want to make is that neodymium and praseodymium prices are actually far more than 50% higher than the prices used in our PEA. And this slide essentially highlights the results of our PEA. The NPV at 8% discount rate post-tax amounts to about $517 million. The IRR after tax is 18%. We have a 5 years payback period with initial capex of 440 million Canadian, which is about 350 million US. As I mentioned before, we are planning to produce about 25,000 tons of total rare earths. One unique characteristic of our deposit is our ability to produce a high-grade flotation concentrate. And that is a key important characteristic for rare earth projects that makes projects more economic. And I will explain to you a little bit more about that. Our mine life at the moment is 16 years. It makes the project robust and viable from a preliminary economic assessment perspective. But we believe we can we believe we can increase the mine life because we have just doubled the amount of drilling that we have done. We so far have results for, I should say, we drilled 4,000 meters and produced a resource estimate that was used for this preliminary economic assessment. Since then, we have drilled another 5,300 meters that are not yet reflected in our resources. And for this reason, I believe we should be able to significantly increase our resources and mine life. In addition to that, there's other highlights. You can take your time reading it later. I'll bring to your attention some of our price estimates. The average price used for the concentrate was about $5.76 per kilo. And for the precipitate price is about $14 per kilo. So why do we believe we have a robust PEA? For the reasons I've indicated. The graph on the right shows the sensitivity table of NPV to changes on average long-term prices. And our base scenario shows about $500 million, but if we were to use spot prices, according to that graph that I showed you earlier, it would have been much higher, north of 1.6 billion. Using the prices today, it would probably be north of 2 billion. So in that sense, we believe we have a very strong project. If you believe that prices are likely to stay at this level or potentially higher, you will appreciate that we have a very good potential here for much higher valuation. On the left, there is also a sensitivity table or graph of NPV versus CapEx and OpEx. And if we were to be off by CapEx or OpEx by 50%, we will still have a positive NPV. Now, we think that our engineers were very conservative, SRK, but even if they were, we'd still have a positive NPV, not a glamorous one by all means, but still viable. Important characteristics when you're looking at mining projects in general is to look at infrastructure. So comparing to other mining projects, or specifically to other rare earth projects in Canada or in North America, WICHEEDA has very good infrastructure. We are 80 kilometers from Prince George, and there is road that leads directly to the property. We have just a few kilometers away from our deposit. We have power lines. There is also nearby major gas pipelines. We have Canadian rail. So it is very, very well positioned. In addition to that, only about 500 kilometers away, we have a major deep sea port, the Port of Prince Rupert, and can be accessed by rail or road. So this is a profile of our block model and conceptual pizza shell. I'm not going to spend too much time discussing the geology or these results, but I want to bring to your attention that at the surface, we have very high grade, so which is represented by the lighter colors, the yellows and the lighter greens. And you can see here the scale of 50 meters, and this is really positive. What the implications of that is that in the first few years, 7-8 years of our mine life, as projected by the PEA, we will have a strip ratio of about 0.63 to 1, which is really good. This slide presents our total resources. So we currently have, as I say, from only about 4,000 meters drilling, we currently have about 5 million tons indicated resource at 2.95% TREO, and roughly about 29.5 million tons of inferred resource at 1.83% TREO. And the praseodymium neodymium account for about 15% of our total rare earth, which is similar, for instance, with MP materials, with the Mountain Pass deposit in the United States and other deposits. But obviously we have all the rare earths. So we completed recently another 5,300 meters, and we believe we will be able to improve the categories from inferred to indicated, as well as to expand the resource. We believe we have a pretty conventional rare earth flow sheet, in the sense that we are able to, after mining, crushing, and grinding, to go straight into flotation and produce a sellable product, a mineral concentrate with more than 40% TREO. That is a unique characteristic of our deposit. There's only a few projects in the world that can achieve that. And most of the projects that are in production today produce a mineral concentrate. In fact, it seems to be an important characteristic, almost requirement, call it, in order to have an economic rare earth project. And we have achieved that. After producing this material, which we will sell in the first few years, to then fund the rest of the project and build a hydrometallurgy plant, where we'll do the leaching and purification of the product to produce a sellable hydrate precipitate with high-grade rare earths. And the price, as I indicated, will be sold according to the PEA. These are our forecasts anyways, $14 per kilo. The model today does not envision the separation yet, but depending on the market and depending, of our position in the future, we can also continue going downstream and separate the elements. But for now, we will be following a model similar to MP Materials, which, by the way, is a $7 billion market cap company. So this is probably the most important slide that I will be showing you. It compares our project with other projects and other producers. And what I want to bring to attention is that the three largest producers in the world, which includes MP Materials, as I said, $7 billion market cap, the Mountain Pass deposit, Lynas Corporation, also with about $7 billion market cap in US dollars. They have the Mount Weld deposit and BioNoble, as many of you know. So all of these producers have a much higher grade than we do, as you can see. But the important point, so for instance, if you look at Lynas, the 7% grade on average, they produce flotation concentrate with 40% total rare earth. Although we only have about 2%, we can increase, we can concentrate our minerals and produce mineral concentrate flotation with more than 40% total rare earth. And this is a unique, as I said, characteristic of our project, and is similar to other economic projects around the world of producers, and is one of the major aspects of our project. So there are other projects in Canada, like the Ashram, the 2% roughly grade, and because they're fine grain, they are not able to upgrade as much as we do. The Strange Lake deposit is a heavy rare earth deposit with minerals that carry heavy rare earth in higher proportions than light, but those tend to be rather unique minerals and found in smaller concentrations as well, and difficult to upgrade. These minerals usually have total rare earth at smaller contents compared to paratite, bastnaesite, and monazite that have higher content of total rare earth, which is usually more than 60%, more than 65%, and sometimes higher than 75% total rare earth. What means is that when you concentrate paratite or bastnaesite or monazite, you end up with a higher grade if, of course, you have a coarse grain deposit like we do, or you have a high grade like Lynas has. Another project in Canada that has reported to have produced a mineral concentrate, a high-grade mineral concentrate, is the one that has the Nishalaka project, where they have a high-grade zone. Is a small high-grade zone, estimated at this point of about only about 100,000 tons, which leads to about 9,000 tons contained resource. But they are able to produce, or they have said that they are able to produce a concentrate as well. And that is very positive to them, which has resulted in a high market cap. As you can see, they're listed there in the Vital with 183 million market cap because they are at that stage where they can produce and sell that high concentration product. We are just out of the gates here, offering a tremendous opportunity to our shareholders. Like I said, we just acquired 100% of our property, and we just filed for the PEA, leaving us in a similar position to many of our peers and offering a tremendous upside to our investors. We are in a strong position because we check all the boxes for a successful rare earth project. We have favorable mineralogy. By that I mean we have the key minerals that, when concentrated, you can basically produce a high-grade flotation concentrate that makes your project more economic, and you can follow the MP Materials model of selling that concentrate. And we have already parties very much interested in buying it. We have a good resource, which we have drilled more and is expanding. We intend to use a conventional metallurgy, the same that has been used in BioNoble and Linus, and we believe it's significantly lower risk than others that have complex minerals and have to come up with different flow sheets. We also have excellent infrastructure, which is a key point for any mining company. We have experienced technical team, and we already started the long lead environmental work. So what are we going to do for the next 2.5 years? So we intend to accelerate this project as much as we can, while being obviously cautious of doing all the necessary things to de-risk the project. So we will continue drilling, infill drilling, and doing expansionary drilling to increase our resource. And we will also continue de-risking our metallurgy. So we will continue to optimize the hydrometallurgy and the flotation. And this year, we will be doing some pilot plant tests. And we will use all this information to start this year our pre-feasibility study, and hopefully complete it in the next 12 to 15 months. And then from there on, next year, we will be starting to prepare to produce, to build, construct a demo plant to further de-risk our metallurgy by scaling up the tests. The demo plant should be anywhere from 5 to 10% of the total commercial plant, full-scale plant, and that will be critical to de-risk our metallurgy and our flow sheet. Once we've done that, which probably will take the pre-feasibility and then the feasibility study, probably another 2 years or so, we should be ready then to do the financing for this project. Our technical team includes SGS Canada, as many of you know, a leading laboratory. They have published a report or paper about our deposit, and they are in the process of doing another one. And they have done a tremendous good work, and the sharing with others the successes of this deposit. SRK Consulting is an international consulting firm. They are helping us with our economic studies. Apex Geoscience is a leading geological service company. We're very happy to have them support, and they're helping us expand our resource. And Sinosteel, which is a Chinese company with extensive experience in building rare earth facilities in China and outside China. As you know, they were the ones that, as some of you may know, they were the ones that built the demo plant for Northern Minerals in Australia. So, as I mentioned earlier, I am the president of Defense Metals. My background is engineering. I spent many years covering rare earths, traveling the world, looking at this project. Craig Taylor has been the lead person for defense metals, bringing the project to the state that it is today in about 3 years to complete the PEA and acquire 100% of WICHEEDA. We have brought on Dr. William Bird recently as well. He was the president, CEO of two rare earth companies, Rare Elements and Medallion at one point. But he left those companies and he's very excited to join us. Ryan Chung is our CFO director with capital markets experience. Maximilian Sally, he's been as well in the rare earths for a long time and in the capital markets. So Andrew Burgess, he is ex-Spectrum, which was the vendors of the WICHEEDA project. And Chris Ruffle is our QP and director for the project with significant experience in geology. So I finalize by presenting you our disclaimers and forward-looking statement disclaimers. Please read it at a convenient time. Thank you. I'm ready for questions now.
Okay, Luisa, thank you very much for the interesting presentation. We got in a few questions for the attendees. Please don't hesitate, everyone. This is your private access to the company's executive. This is why we make those events. So for you investors or prospective investors, have a chance to ask your question directly, and all executive and all CEOs and companies member will be happy to answer all your questions. So don't hesitate, make the best use of this event. So Luisa, we have obviously a few things we need to discuss. Rare earth element is at the center of the electrification of the transition in the energy sector that everyone is talking about, that we have on everyone's lips. But it is still a market that might not be understood deeply by everyone. It is a complicated market. It needs a lot of chemical understandings and so on. So without maybe going into details, I would like to maybe talk a little more about your way into this sphere, what led you to this position right now, and the specific knowledge you have that is required for such a position that you're occupying, and that you discuss a little more about you.
Sure, no worries. So I'm an engineer. I study physics. I have a PhD in material science. I don't think folks need a PhD in material science to really understand rare earth, but it definitely helps to follow the sector. And so I guess this is has been one of my strengths, to be able to read and understand the metallurgy of these materials and mineralogy and how and what is important, to make a successful project. And so, rare earths don't have to be complicated. And there are really only a few minerals that have been used in the rare earth space commercially. And investors are to look at that. If there is a company with a project with minerals which are really unusual for the space, you have to be asking the questions. If it's a hard rock deposit, simple questions: are you able to produce a mineral concentrate? And if you're not, what sort of grades are you leaching these products? And that is, a very simple question. It's something very simple for investors to be looking at, because obviously, if Bionovo, Lynas, and MP Materials, they are processing or leaching a rare earth concentrate with more than 40% content, and somebody else or others are trying to develop projects where they do that with only a 5% or 2% or less in many cases, that there is immediately a difference in economics. So that is one characteristic. That's something that investors can keep in mind and ask companies how they think they're going to be able to solve that issue. So like I said, I've been traveling the world. I've seen many projects, but I actually, when I was an analyst, I didn't know about this project because the owners of the project, they understood immediately the strength of WICHEEDA, and they tried to keep it private and do it themselves. So unfortunately for them, the markets of rare earths collapsed, the prices collapsed, as we all know, after 2011, and we were left in a precarious situation. And so they then decided to vendor it in and bring it public. And we, Defense Methods, is so fortunate to have this project, and which has a very strong potential to reach production.
That's very interesting. So I'm going to pick up on the two characteristics you said. So basically you discuss about, are you able to produce? Ask the question. So you put in your timeline that you would have an hydromet pilot plant, so not a demo plant, but really the first version of it. Do you have an idea of the cost associated to it? And what are the expected results from this? Where does that will bring you in terms of advancing the project?
Well, just to answer immediately where that brings us is really the scaling up, because a lot of the work many times is done at small scale. So you will be de-risking by processing much larger volumes and understanding how the whole recoveries, and costs and consumptions of acids, all these details sort of come together. So that is really an important aspect. So in terms of the cost, that plant's likely going to cost us $2.5 million. And we are currently actually looking at raising money to continue to develop the project.
Great, and that leaves us, leads us into the second one. So maybe for the benefit of all, so we have a question that came in and basically asked about the split percentage of purchases in different countries. So what does the market looks like? And that, I think, is one of the very important points we're going to have to discuss. Market of rare earth, what happened with the supply chain? Why is it critical right now? So maybe if you could englobe all of that in an answer, that would be great.
Sure. So the way the market looks right now, as I said, so if you look in terms of production, right? So we have China accounting for about 60% of the world's production, mine production, I should say, of rare earths, and then followed by US with about 16% of that. And then you have Myanmar, and then you have Linus, and they account for the largest production combined of mine production. But and then when you look, as you go down the, if you go downstream in production, let's put it like that, China accounts for more than 85% of the separation of these elements. Okay, so the China still is controlling the separation of rare earths, the refining of rare earths. And so a lot of that stays in China as well. So if you start thinking about consumption, which was the other side of your question, China still consumes about 60% of the total rare earths. And then they export part of it to the United States. I don't know exactly, haven't tracked for last year, but it's probably United States, probably around 10, 12%, Europe as well, in terms of the consumption of these separated oxides. But what happens is that the rest of the world is likely consuming the majority of the rare earths, if you think indirectly, because although China consumes the largest volume of oxides, a lot of these oxides are transformed into metals and other products for lighting, for instance, and then exported to the rest of the world. So Europe and the United States end up consuming a larger percentage of total rare earths when you start looking downstream, if that answers the question.
Yeah, that's a great answer. And it leads us into very, very interesting direction from here. So basically, we have a few questions that are also asking if you're right now currently in talks with any companies, if any of those companies, where they're located in the world. Obviously, there's some information you cannot divulge, so I'm not asking you to drop names here, but how is the interest of parts producing, of magnet producers towards your company and towards your project?
Well, I will say that magnet producers and those that use rare earths in China, as well as outside China, are very interested in securing rare earths. So just the fact that prices of neodymium, praseodymium have gone up so significantly, I think it's a reflection of the demand for some of these magnet elements. So in terms of the interest for our product, we have seen significant interest as well. Although we only have completed the PEA and working towards our pre-fees, and we are at least 2 years away. We could do it faster depending on the markets and so forth. But we are a junior, and despite that, companies are extremely interested. If we had a mineral concentrate today, and if we had a mine producing a mineral concentrate today, like MP Materials is, we have a market ready to export it. So we do have parties that are interested. We are a small company, and for this reason, we have not yet engaged formally with anybody. And we also a few years away from production, but we will be doing those contracts. Companies, they are approaching us and asking us to give them updates, for instance, every 3-4 months. That was show to us that they want to understand our progress, and frankly, they are desperate for it. They're desperate for errors, especially those outside China.
Perfect. That brings us back to project timeline. So we have a question asking about the determinants of the project timeline: regulation, engineering, and I would add to that maybe ESG planification. We know everyone's discussing about it. Everyone has an eye on it. Some people are talking about using renewable energy for a mine site. Other people are discussing about water usage. But basically, rare earth has a very big environmental footprint in the world right now when it's separated, when it's produced. And it might be, in my humble opinion, one of the sphere that needs a lot more work on the ESG regarding mining. So can you tell us a little more about the timeline of your project? Maybe even go back to the slide, telling us what we're expecting in terms of regulations, in terms of engineering, and then obviously what's your planification on the ESG factors.
Right. So we actually reported early in the year our plans for the year, and we indicated that we will be engaging a consulting firm to help us adopt ESG standards, and we're looking forward to that. It's going to happen soon. We will be announcing, and so it's important for us, and I think any mining company is looking at really bringing those ESG standards into their operations. So we will do the same as soon as possible. Now, regarding the processing of rare earths do have a very bad report for some reason about processing and the environmental sustainability of it all. And I think in part the reason for that is because folks have seen images out of China of how iron adsorption clays are processed, and often you see folks, covered in mud, and it looks really a very dirty process. However, if you were to visit MP Materials or Lynas in Malaysia, you will see a very clean project. A very clean production. And as well, it's in China. The major producers have a very organized process. So I would say that, what we talk about here, the hydrometallurgy for rare earths, whether it's flotation or whether it is leaching, it is pre-conventional metallurgical processes. Now, the issue for some companies, and I think many have in mind perhaps the Greenland issue, the project was blocked recently. That project was blocked because of the uranium. Rare earths are usually associated to radioactive elements like thorium and uranium. And in the process of doing that, you have to separate those elements. And countries that do not like those elements, don't want them produced, usually react negatively towards that. It's not so much the rare earth itself. The separation of rare earths is using conventional solvent extraction processes. Obviously, you have to use unique reagents to collect and separate the rare earth. However, it's not because it's dirty. It's just that there are rare earths and they have similar physical chemical properties, and separating them might be complex, but not necessarily dirty. So that's something that people need to understand. The issue of rare earth is their association to uranium and thorium. And when countries and provinces in Canada, for instance, don't want production of those radioactive elements, then it becomes difficult to develop. But Canada is a major producer of uranium, and we don't have the same sort of issues. Definitely, we do not have the same issues as Greenland. We will not be producing uranium. We have almost no uranium in the deposits, like 2 parts per million. People have more uranium in their countertops than we have in our deposit. So, this is a very important point that investors need to understand when they think about rare earths.
Great. And as you said, this is a very important point. Mainly, it would be my personal takeaway. But for everyone that attended your presentation, so again, we thank you very much for that. It's 1:58, so we have about a minute and a half to go. Maybe in a nutshell, right now we're doing this, it's virtual events. If you had the participants right in front of you, what would be that last sentence, the takeaway you would say, this is exactly Mr. X, Mrs. Y, what I want, that one sentence, what you wanted them to remember directly from Defense Metals?
I want them to remember that Defense Metals is just out of the gate. By acquiring the property and completing the PEA, is in a similar position now to other juniors in the space. And it has the strong characteristic of being able to produce these high-grade mineral concentrate like MP Materials and other producers, which puts the company in a very strong position. And so we have most likely one of the highest chances to come into production, and investors should continue looking at us because we're offering more potential than any other company right now.